When I first installed my first LoRaWAN sensor, it was actually a sensor that I had invented. Thank you. And when we installed it, the first thing, there we go. So when I put it in there, the first thing that I was thinking is, oh boy, we have just created a device of our own. We have bought into the hype of the LoRa radio, and we really hope that what we have created works, and that it works well. We had big customers that wanted to deploy, and our opinion was that we had bought into what LoRaWAN can do. We bought into the hype that it is a very powerful radio, it can reach really well, and we thought that all that we needed was our sensor with the power of LoRaWAN and a gateway close enough and install it. And the reality, though, was that it went into a pretty horrible place. If you ask your customer, or they ask you, how far can LoRaWAN reach? We naturally want to say, well, it can go 10 kilometers or something further. And where will they put their first sensor? They'll put it 10 kilometers away, the worst possible place that you would ask them to, or they'll put it in the ground, or they'll put it somewhere that is entirely inaccessible. And this was the reality that we faced. Interestingly, though, our first devices, even though they were being installed into places that looked like a submarine in the bottom of the ocean, it still worked. It was inside of grounded steel boxes, and it was still able to communicate out through those boxes. Now, it didn't go very far from there, but at that point, it didn't matter. We had actually accomplished what we were after. But you might recognize some of the work that I've done before. I am the founder and the original inventor of Vutility, which makes a wireless current transformer. I am also the founder and inventor at Deviceroy, where we make some other very interesting technology. And that's relevant to the conversation. And the reason that I bring this up is it's important that you understand that I've been doing this for a few years. I have quite a bit of experience deploying LoRaWAN and designing things that use LoRaWAN. We are the first certified device in the world for Amazon Sidewalk here at a LoRaWAN conference. I doubt that you really care, and that's okay. We're also a member of the LoRa Alliance. Both of my companies that I've created are a member of the Alliance. And so we've been doing things since about 2015, and we've had a lot of experience doing LoRaWAN. The big question that I am asked a lot about as to why I created the relay, or why we added it into our existing device, was last year we were approached by Semtech and the LoRa Alliance, and they asked us if we could add the relay capability into our device. And the biggest reason that they asked us to do that was that the Aria that we built is a pretty extreme device. It is meant to communicate with existing machines using their existing protocols and be installed out in the middle of nowhere. In fact, we're often installed on solar inverters, and that's a pretty remote situation, especially in utilities. And then we started getting pulled into other markets. So when we were being installed in solar, we didn't really see much of a reason to use relay. We had wide open spaces, we were up off the ground, and so the normal restrictions that you might encounter with LoRaWAN, we were not experiencing. But our clientele changed. It started adding in new industrial customers. We started going into oil and gas. We started going into refineries, and then into the middle of nowhere where they're actually pulling oil out of the ground, and they're wanting to modernize their infrastructure. In those particular situations, we saw that we started encountering the same problem that probably everyone else experiences in LoRaWAN, which is it works until you get that weird scenario or that weird place where you think it'll work and it suddenly doesn't. And you're starting to deploy devices out into the middle of nowhere, and you start to hold your breath that they're still going to work and they're still going to connect, and you start getting sporadic experiences. So for our experience, especially in oil and gas, we had an enormous amount of interference. For those of you who know anything about radios, metal and liquids are not very friendly to radio. Now, LoRaWAN is certainly stronger than the other radios that are in these environments, and they've tried everything, right? They've tried cellular, Bluetooth, as crazy as that sounds. They've done Wi-Fi, and they try and do things that are low power and long-range capable, because inside of an oil refinery, you can't exactly stick a gateway in the middle of a building. There may be explosive gases where you simply cannot plug in. So you need to get from one end to the other, and this infrastructure is blocking it. We also saw a lot of situations where, especially in the Permian Basin, which is one of the world's largest areas of pulling oil out of the ground, a lot of it is just in the middle of nowhere. We're looking at an area of, about 100 kilometers by 100 kilometers. Actually, no, it's more like 300 kilometers by 300 kilometers of nothing. There is no cellular connectivity. There is no Wi-Fi. There's nothing. The only thing you can see is the sky. And how do you get a signal from the middle of nowhere where they're pumping oil out to the perimeter and keep it moving from there? LoRaWAN does a great job. In fact, we can get even more than 10 kilometers. We can get a lot further than that when we're truly outside. But then the weather happens, rain happens, it gets cold out, things start freezing, and the signal degrades very, very quickly. We also encounter, which I'm sure you've seen in many cases, in a lot of the conversations, even today at the show, a lot of people install things in the ground, especially in water metering and other types of utilities. They'll go into basements or just outdoors, and radios don't like turning right turns, right? So if you're down hole in the ground, where is the signal going to go? It's only going to go straight up, but it's capped by a giant steel plate that loves to absorb and block signals. And so you might get the signal out of the hole, but it's still just going straight up into the sky and not horizontally. And that was also a challenge that we were encountering, and I think a lot of you are also experiencing that with your sensors. So these were really complicated challenges that just deploying a sensor and hoping the gateway can get it, it was just becoming impossible. Fortunately, the LoRa Alliance and Semtech saw that we needed to have something that could solve that. So that's when they brought forward the concept of the relay, and it's now a specification that's available. You can read it, it's pretty dry, but they have that for specification. It's important that you understand, and this is where we're going to start getting into some of the meat of how the relay works. If you have a sensor that you're hoping that you can start using relay, there are some important facts or caveats that you need to be aware of. And this is the first one, which is it takes three things to make the relay work. You need to have a relay, which fortunately we have. In fact, just for a size reference, this is the size of the Aria. It's quite small. And this is the first relay that's available on the market. It's available globally, so you can use this right now to extend your sensors. That being said, you do need to have a LoRa network server that is relay compliant. The relay is controlled by the LoRa network server. It is a whitelist system, which means that it's not going to automatically relay everything that you want. It will only relay the devices that you tell it to, and that's controlled by the server. So you don't have to do that on the ground, so that's good. You can do it remotely, and you can update it whenever you want. You need to have the relay, which I just showed you is the first available one. And then you need to update your end devices. Your sensors need to be updated to support the relay communication. For those that are using the 1270 series of the Semtech LoRaWAN or the LoRa radios, up until very, very recently, those were simply out of the opportunity. The relay specification takes advantage of unique hardware or unique improvements in the newer radios like the 1260s and the 1280s and the 1120s. But fortunately, they now have experimental code. This is available directly on the Semtech GitHub repository, so you can have your engineers download this and immediately start testing with it. Other than that, everything else that I mentioned is officially supported, aside from the experimental code. But the good news is that really just about anything out there can be updated, provided that your device can accept the firmware update over the air, or if you have another way to get that firmware in there. Otherwise, you're probably going to be only doing this to your newer devices. Some of the reasons that you'll want to update here. The LoRa Basics modem is what they call the new code. It is not the LoRa Basics station. I get that question a lot. And in fact, for those of you that will have probably a lot of questions, we are just on the other side of this veil right here in the ThingStack booth. So you can come and ask us any types of questions that you want. On our website, we also have a blog where we answer over 50 questions that we commonly get from companies that are trying to move forward and introduce relay into their devices. So if you have questions, those are great places to go to start understanding it a little bit better. But the LoRa Basics modem is what you'll have to update your device to. And it's very important that you do that because it's not only that you're getting the relay capability, but you're getting built in the firmware update over the air code that Semtech has worked on, which is a really nice improvement. you're also getting device-to-device communication capabilities for those scenarios where you need to trigger on-premises two different things, an event that causes another sensor to do something. So there are a lot of nice advantages, including better battery management. But moving on, though, so you also need to know that the LoRa Basics modem requires LoRaWAN 1.0.4. So if you're on something older than that, or even something newer like 1.1, or hoping to try out 1.2 as it comes out, those are not, the newer ones are not yet supported, although that will come very quickly. And the older versions, you will need to migrate into 1.0.4. Some radios, as I mentioned, were not supported, such as the 1270 series. Fortunately, they recently added in that experimental code to make that possible. I know that in the case of water metering, there are a lot of companies that have been using the 1270 series. It's a solid radio, so it's a good thing that they've done that. The relay is not a gateway. A lot of people think, well, I can just use this and I can connect it directly in. I don't have to put in a gateway and use the expensive connection. I don't have to have cellular backhaul or find a way to power it. That's not true. The relay is intentionally trying to extend range to the sensors that you're having trouble with, or get it to something that's downhole that needs to go out in a new direction. This is not a replacement. Now, if you've been using gateways as a kind of a pseudo relay, this is an excellent change and a nice upgrade. So the relay, some of the advantages that you're going to get out of using the relay capabilities are that you're going to get a much better range. Right? It's basically, you're adding the range capability of another LoRaWAN sensor. And in fact, if you position it well, you can get far better than double your range. But if you stick it in the ground, you're going to get terrible range. So think about how you're going to place the device. Right now, there is a limitation of 16 sensors per relay. Now, you can have as many relays as you want inside of a network. But right now, because it is a whitelist system, you have to tell the relay from the LoRaWAN network server how many it's going to support and which DevEUIs you're going to allow. And the reason is because, again, as you're using an in-node sensor to do relaying, it's a single channel. So you're going to load it up pretty quickly. Now, 16 isn't very many. And as we were working this code out for the first time with Semtech, that was one of our first pushbacks. And we said, 16 is not impressive. That's not going to get anybody to bite. And so it's already in the LoRaWAN relay work group that they are updating to increase that number. They needed to have a real world situation to see the true math of how it shook out rather than just theoretical. And now that we've done that work with them, that number will go up very quickly. The ability to improve the battery life of your sensor is one of the really valuable advantages of the relay. When you're using a sensor that's at long distance, you're going to be pushed into a really poor data rate. You're going to be on a really unpleasant spreading factor, and it's going to be chewing up your battery. Right? If you're using ADR, or which is the adaptive data rate, the challenge is that it's going to push it to try and be heard. You're going to be on air longer, and that uses up the battery. Your sensor is going to have to be traded out more often, and your customer is not going to be very impressed with your sensor. But with a relay, it's sitting in the middle, and suddenly it kicks you into a very high velocity data rate. Your spreading factor is optimal. Your battery life is going to go through the roof. The option, if you choose not to move into the LoRa Basics modem, whether you're choosing to use the relay or not, is that if you don't do that, you're going to simply be planning your own obsolescence. This is the next generation of where the code is going and where the capabilities of LoRaWAN are. Newer features are going to continue to be added on to this code from Semtech, and it's important that as soon as you are able to start migrating in, that you do that. There will be some challenges with your engineers. There are some pretty interesting paradigm changes that occur. We've answered a lot of those questions on our blog, and you're welcome to go and take a look at those as you have your engineers try and figure out how to move forward. That being said, because we did it, we were the first ones to go through the process, we know what some of the gotchas, actually, we know what all the gotchas are. If you feel the need to shortcut it, and I wish I could give more information than in a very short presentation here. But if you feel like you would like to shortcut it and not have to go through the same process that we did, by all means, contact us. We do not charge to help you to understand and get past some of the things that we had to figure out the hard way. Right? At the end of the day, if you are moving into something that is relay compliant, well, that's good for our business because we happen to make a relay. So we're happy to help customers understand those things. Bear in mind, we are not the Semtech FAE. If you have an FAE, it's a good place to start and talk to, although they will probably refer you to us since we've done the installations and the setups ourselves. That is, in a nutshell, the relay, and I, again, wish I could give you more detail than that, but by all means, come and chat with us and dig in, ask any technical questions you like. I'm Steve Ellis with Deviceroy. We have like a few seconds to answer questions if anybody has a hot topic that they want to ask real quick.
Is it possible to cascade relays?
It's a great question. You cannot hop multiple relays across each other because every time that you take a signal and move it into a relay, it's encapsulated into a new payload. So you're taking all the information of the original packet and putting it into the payload of another packet. So it starts to get bulky very quickly. We have asked Semtech and the LoRa Alliance if they can allow us to at least add one more. It is under consideration. I can't give a better answer than that right now. But yeah, that's right now it's just one hop. Yep.
Devices in the field that will be going through the relay also have to be updated.
If you can get the mic right there.
Was it so that all the transmitting devices that are out in the field have to also be updated when they're going to be going through the relay device?
Yes, so the devices that are going to use a relay do need to be updated. They send a special wake-on radio command out to the relays that they are authorized to talk to, and the relay then wakes up and is aware that it's ready to start relaying. So that's an important one for relay. The good news is, though, that if the gateway happens to be closer or able to hear it better for some reason, the gateway will automatically just handle that transmission. I think we're probably out of time. But again, if you have more questions, please come over and have a conversation with us. We're happy to help out. Thank you.